Hello, everyone. I'm going to present EcoLight, a reward shaping scheme for environment-friendly traffic signal control using deep reinforcement learning. It also includes Sumo implementation. This project has been done by me, research assistant at Simon Fraser University, under supervision of Mo Chen, and the Breeze Traffic, Alexi and Alessandra. So what motivates us is $124 billion per year is devoted for traffic congestion. 1% cost of European Union is devoted to that. 3 million deaths has been reported for air pollution, and 30% of that was because of the traffic. Whether traffic signal control in China reserve 50% of the delay. If you want to take a look at the industry implementation, we can see that we have two categories, the non-learning approaches and the learning approaches. On non-learning approaches, we have the uniform fixed time to actuate the traffic signal control, which we have some sensor to detect the vehicles. And then we have the Webster, which try to optimize the cycle-based approach and self-organizing traffic signal light. However, on the other side, we have a wide variety of different learning approaches. But in here, we want to talk about EcoLight. So how EcoLight is different from other approaches? We have a reward shaping scheme, which is different vehicle type. We are considering different vehicle type, like the car, the trucks, and we are directly targeting CO2 deduction. So we have complex single intersection, which includes the direct movement, left turn, and right turn. So if you want to take a look at the agent design, we can see that we have a deep RL structure, which actually use the tabular Q, DQN, SARSA, or A to C algorithm in here. If you take a look at the structure, you'll see that the only difference from the conventional approach is that we have an objective which tries to directly manipulate the reward, which is a weighted scheme of the usual reward algorithm that we have in the literature, like the pressure, the weighted weighting, the waiting time, and the Q length. The action spaces are the next green phase, which is one hot encoded. So how we are going to select the weights? There are two different approaches. The first is the constant approach, which we optimize one constant value for each vehicle based on the class of the emission. The other one is the normalized emission, which we have a unique weight for all of the vehicle in each lane. And the adaptive weight is something that is based on the current emission of the vehicle, and it is different for individual vehicles. As you can see on the picture, we have a different parameter for the weights, and we can see that some of the approaches are on the upper side, which provide less travel time. However, some of them provide less CO2 emission, and some of them are in the side where it can provide better travel time and CO2 emissions. So there is a correlation between them. And here we want to present the experiment. We will see, as we mentioned earlier, the travel, since we are reducing the CO2, the travel time is also reduced. Waiting time and stop time also the same. So if, as an example, the waiting time, A to C approach, we will see that there is a reduction in the travel time. And we see on the figures that regard the fluctuation in the traffic, the profile of CO2 emission, the stop time, travel time, and the reward are kind of steady. And here we have a comparison between all of the different approaches. We can kind of see that the weighted waiting time of the SARSA approach can provide the best result among all of the different criteria. And here we'll see the experiment, a side of the experiment. On the right side, we see the fixed time approach. And on the left side, we see the SARSA. As you can see, the left on the right side, the blue triangle, which represent the trucks, are trying to move to the from the south to the left. They are stuck over there because it's going to be like one cars at a time, which produce a lot of delay and a lot of CO2. However, this problem is solved on the other side. So in this project, we proposed the EcoLight, which was an approach and a reward shaping scheme that can provide a good result for traffic signal control. Thank you so much.